What are they, the temporal tables, and why they are in SQL Server? This is a new type of table, which is pretty much similar to any other kind of table. And it provides information about stored data at any point in time. In other words, if we want to find out what a particular record, for example, a customer's address or a phone number used to be 10 months ago or on a certain date before it was modified, we can very easily do that using temporal tables. For example, uh, what do we mean by this time travel? It is simply traveling to any point of time and compare data between current date and any point in time in the past. We can also compare it with any between any 2 points in the past as well, entering specific date and time for start and end. Data audit is another very important part and step achieved by introduction of temporal table, or also known as system version table. It is easy to recover data in accidental case, either by human error or application, using temporal tables. We can simply go to history, pick a particular data element, which is correct, and update it without backing up on it and restoring the entire database as we used to do in the past. And also, it is a very concise and clean code in terms of T-SQL. What we mean by concise and clean, we don't need to write any cumbersome applications using Visual Basic or .NET C Sharp or C++ or Java or any language, which makes it a little bit cumbersome and hard to integrate with the SQL Server backend itself or with the other components, especially if there is no direct need for such integration and additional testing. We don't need any parallel replication. We don't need to use triggers, as I used probably 15, 17 years ago when I first had a need to historically audit data in a particular database. It took me almost a month and help of two other people to develop, test, and deploy a solution like this. And of course, we all know why triggers is not the best at all approach to auditing tables, primarily for performance reasons. So that really explains why a different type of solution is sought and preferred for data auditing tasks. What are the temporal tables? They are, again, just like any other table in the database, just a different syntax is used, a slightly different concept in creating them using T-SQL. Let me start with opening SQL Server. I will open, not going to need an existing project. Let me open SQL Server Management Studio. That is Management Studio that I hope you all have installed at our first class. And let's say I will go to an instance of 2016 and really grab any existing database such as AdventureWorks, which we all know, or something simpler and familiar to everyone, such as Northwind. So let's see if we actually are ready to create a fresh table as a brand new example. As usually DBAs are very interested to see how things are created from scratch in terms of how they are going to support a solution. Um, so let's start with create a brand new table using T-SQL. I can probably paste it later for you to download. So let's start with create table. And we will call it, let's call it departments. Using the full qualified syntax with DBO schema, database owner, which is simply a good practice. You don't have to. So let's call it departments using a common syntax. Let's say I will just use a short version. I will not fully qualify every field and every table name. Let's say we have department ID. Make it integer. Let's well, obviously it's going to be not null, and it must be a primary key. The table must have primary key, which is also in most cases is a clustered index as well. It is important for implementing temporal tables. Sorry, let's call that clustered. And the next field, let's make just a couple of fields. Department name, make it var character 50. And also not null. Otherwise, why are we going to even have this data if we plan to have nulls in it? Manager ID integer null. It may be pointing to any other table as a foreign key, for example. Can be and it can be equal to employee ID in employees table, etc. Doesn't really matter. As far as the implementation of primary key, usually we know that it is not necessary. However, it is a must-have feature for implementing temporal tables. So this is a regular table, as you can see. It has nothing to do with any temporal features yet. So let me run it. Make sure that it is created. When we refresh it here, we're going to see that, that was a blunder. Don't do that. I created it in master. So we want to make sure use, I'm using this test database. It is called DBABL. And so from here, when I run it, we're going to see it right in this database. It is departments. Obviously, the table is empty. There's no data in it. So before we enter any data, that's the whole point. We want to enter different versions of the same data and then very easily travel back in time using this new feature called temporal tables. So let's just proceed with adding another column, which will obviously be a date time kind of column. We do that through alter table. Again, this is a basic DDL that you all know, and I'm not pausing here to explain anything. We are adding a new column. Let's call it sys start date. Sys start date. We are all working without video here. There is not really a video presentation, and there are only 3 of us. In a few minutes, there will be 4. So let's add another column, and we'll make it date time 2, a new data type as well. Now, the further syntax, this is a new DDL syntax, generated always as row start. For some of you, it may definitely seem bizarre. It seemed like that to me the first time I saw it. Constraint. Let's call it default. Departments. Default. And it's going to be sys UTC date time. Also not null, obviously. And let's add one more column that's called sys, and we can, for consistency purposes, we call it sys end time. Date time 2. I purposefully make a different first letter here, so that just to remind you that it is not case sensitive. Now, it's also going to be generated always, typing always lowercase on purpose again, as row end. Constraint. But we also will assign a default to it that we will consistently call, just similar, sys end date. Now the type of object is default, and then there is something here that we are not familiar with. Oops, it's a misspell. Isn't that beautiful? SSMS always will underline a misspell or invalid syntax. So I will explain later why we are converting it to date time 2. You may say, what do you mean? It's already, column is already date time 2. Why do we need this conversion, and why we didn't use it in the first default, in the first new column that we added called sys start date? So I will explain it in a minute. (23, 59, 59). There is a way to use different syntax. I just prefer military time, not because I myself have spent time in the military, but simply because it's a convenient thing when we don't need to worry about that p.m, am misspells, and it's just very consistent 24-hour format. That is my personal preference. Now there is additional. These are all keywords now. Period for system underscore time. And then we're using both columns. Sys start time, sys end time. So we can execute this command, and this is system version, system time period definition, start column name, not matching. So that tells me that I may have simply misspelled the name somewhere. Let's check it. Sys start time. See, this is time, and this is time. And I called the first one sys start date, not time. So let's call it consistently. In reality, is date time, not just time. But since we are doing precision up to minutes and second that we can use to look back historically at the data, We should be consistent in naming columns because this is a very precise syntax that it is required, just as primary key in this case is required for temporal tables. Table. This just creating table by itself does not make it temporal. Does this make it a temporal table? Almost, but not yet. We need one more statement after successfully executing this one that would actually make it fully qualified temporal table by all rules. And that operation can be called enabling system versioning. I'm just putting comments here so that when I share this code with you, you can easily see what each section does. Let me comment this as well. Add the date time column for each step. So enabling system versioning, it's also a very precise syntax, and it's a new syntax. Alter table, departments, and what's there? The syntax is set system versioning equals on. And then we must explicitly name the table which is going to be historical table for this table. Now, let's our historical table will be consistently called history, like same name as this table, either underscore or without underscore history. An interesting thing here that we do not need to pre-create the table called history. So what I mean by that, the syntax here, just to finish this command, is history underscore table. Let me see. I think I forgot exactly how. Okay, equals, right? Okay, so history table, and then we are giving the name of the table that we are going to use as a copy of this table that keeps a version of every row before we updating, deleting, or inserting. In other words, applying a DML operation, data manipulation language, which I will demonstrate just in a few minutes. So let's name the table departments history. Just let me make it uppercase the word history so that we know what we're using it for. That's it. So now, after we run this statement and it completed successfully, now we can see that this is now a fully temporal table called departments. So what is the next thing we're going to do in order to see how it works, why we did it? So when I refresh the tables here, just want to make sure we see only one table, and it says system version. Honestly, I just saw this like in the beginning of this year. Never had to either work with it in practice or anything. Let's proceed to the next step after this. I will use just to show you how this works. So what we are looking at this point is table departments still without any data. We can quickly select top 1,000 rows to see it is empty. It has our two columns, sys start time and sys end time. Now, We can do it in the new sessions or continue here, it doesn't matter. Let's add a record to this table so that we see exactly why we did that. Let's do insert a couple of dummy records. Insert a few using insert into syntax, departments. What we're going to do, we're going to insert into department ID, department name, nice italicized syntax, and manager ID, our three initial columns that we defined. We are not inserting anything into our both date columns. So let's say I will use values one, again, all for demo development department. And then let's say manager ID, I don't know, 10. And then I will just insert the second record. So when we insert both rows like this, it worked. Now we're gonna see, let's not use wizards. Let's say I'll quickly look at the contents of this table, which will be simple select statement, and it just has the data that I inserted. Again, to be fully politically correct, I would need to remove the character qualifiers around integers. Now, what are we seeing here? Just exactly what we entered. We can enter the third row, as many as we wish. And we are seeing the time when the entry actually occurred. So this now shows the time, which is 2028, which is almost 8:30 p.m. And in order, this is the data type of this is UTC date time. I did it on purpose just to show that that we should be converting the UTC time in during the 4-hour difference between U.S. Eastern Time and UTC. Possibly we do it at the end if we have time. Now, after this, let's say I want to update a value. Usually, we will restore the whole database or restore it somewhere in a DR server, disaster recovery, just to simply restore a record, or 100 records, whatever, which we may have erroneously updated. But the situation gets even worse if we delete something. Let's say we delete from departments where department ID equals 1. And let's just execute this statement. So we do not have that row in the table anymore. Somebody comes and says, can I look at this development department? Where is it? Oh, darn, somebody accidentally deleted. Like, this is a small table, it's easy to restore. What if it's a table with 100 columns with really important data that you don't have a record of a copy of anywhere? Of course, we are all having database backup, restores, transaction log backups, different ways we can still restore it, but the amount of work and man hours and effort and error proneness will be like really huge, not really worth something like that. Let's look how easy it is to implement the undoing solution using the temporal tables system versioning feature.
Let's take a quick look at the history table as well, because we're seeing it right here and it's right under the departments table, repeating its columns. And when we're looking at it, our rows are actually there in their previous version. How do we like really restore it, or what are we going to do with it? We can do a lot of things, starting from auditing to checking the correctness, checking what it used to be for whatever historical reasons, who and when did it. There may be multiple reasons why we want to do that. Possibly we want to restore to that version. Possibly we just want to just print a history of how many times names or addresses or anything has changed. How do we normally get a historical data from a new session? From a new session, we don't have to like really cram ourselves into that space of one session. Let's say that we want now to see what was deleted. Let's get historical data. Again, I'm commenting here. Let's declare a variable. Call it consistently, for example, date, um, start date, um, date time 2 equals, and let's say we put like 2020, um, um, I don't know, just for the sake of test, let's do 0915. And that's another variable, end date, date time 2 equals 2020, and let's say we do it 5 minutes ago. 09 um, 27. Well, we don't even have to go down by the minute. And select everything from departments. And it's a different syntax again. Um, this did not exist, had not existed in SQL Server prior to version 2016. For system time from as start date to um, end date, where department ID equals 2. Let's just mark the end of statement. And this is going to show us, oops, at this time, let me see, what did I do wrong? Okay, so how are we getting historical data? I'm just putting a wider range, with tomorrow's date. So let's say everything between this date and this date, we want to see what those records used to be before we updated them. And it is now traceable. It is very easily, in fact, traceable, that we can see that department number 2 used to call this during this time range from this date and this time to 2042. In our case, for less than 15 minutes, for 14 minutes. That's when this department was called this. After this, from 2042, 8:42 p.m. Until now, this is a default for this is daytime 2 data type, and it is called this. So by this, when end time is 9,999, we know that it is current, has no end time yet. Um, and one thing though, um, the question was asked. The question was asked. Um, what are the downsides of using the temporal table and looking at the data this way? Can we use it in every scenario? Can we I don't know. Can we like, for example, truncate or completely drop table? That's a different matter because temporal table does not really fully repeat the functionality of a reverse transaction log or anything like that. There are limitations. There are some obvious limitations of what we can do, and such limitation is truncation. So we can't truncate table, but we can clean it up to time periods. Um, let's say that we cannot actually drop table either, because drop table operation will fail, and we can also we can change schema of column. That may be looked as a disadvantage. As far as truncate or delete, truncate table departments, what's going to happen? Operation will fail because truncate is not allowed on system versioned tables. Well, you're saying truncate is fine. How about if I want just to recreate the table, drop and create it again, whatever, move something into this table, temporarily move something out, then drop it, then recreate, then move records back. We do things like that for many different reasons, programmatic purposes, whatever. Um, can I just delete something? Um, delete is it? Of course you can. As we just showed, drop table departments. Of course, we're dropping uh, not as often as we are deleting, or truncating not as often as we are. I mean, we're truncating table more often than we're dropping. Sorry, it doesn't happen often when we drop table, but still, can we do that? No, because this is a system version temporal table now. Um, so what else is an obvious? So what is another obvious downside? Without going to anything else in detail, let's just see how we can quickly fix this. What do we actually need to do to be able to completely either empty this table, what truncate does, or completely get rid of a table as an object? For whatever reason, we're doing that. It happens a lot in certain staging tables, which we use with ETL processes, for example, based on SSIS or Bridgegate, Talent, anything, any ETL process that often fully truncates and then repopulates. That's the whole point of staging data, repopulated with something else that we import from text files or elsewhere. Um, so what we can do is we can turn system versioning off through alter table, set system versioning equals off. Now, what else would we need to do? We would need to drop, we can also drop period for system time. The way we can do this is through alter table, departments, drop period for system time. Um, can we now drop the whole table? So let's see if we can do this. Do we need to drop the second table? That's another good question. Um, it even oh, wait a minute, what did I do? Departments. Uh, obviously misspelled somewhere. Okay. So drop table departments. Let's say that we still have that table, so we are confirming that it is there. And let's just run this whole thing together like this, or Alt first. Say it completed successfully. We're looking at the tables. How interesting! The history table is still there, even without its mother table, and we still have all historical changes, what particular value of a column, of a whole row, every column was in the certain date range. This is a very useful feature, and we don't have to use triggers. We don't have to do restores from backups. We don't have to import anything from a warm standby server or a replication server. We don't have to do any of that. It's extremely simple to see the values of data. You can easily return the row to the beginning. Okay, so I hope you really enjoyed this. If we want to completely get rid, of course, we can now drop the table department history as well. I hope you really enjoyed the demo. This is an easy one. So let's say if we want to drop table department history, are we allowed to do that? Yes. So now we have no tables at all. Just exactly what we were going to prove that we can do. And this has become possible only because we turned system versioning off on the main table. I call it mother table. It's not an official term. Um, so please feel free to repeat this. You can use 2017 instance. It will be exactly same syntax. Thank you, and we are taking 15 to 20-minute break and resuming somewhere 5:10, 5:15